Whoa. Okay. Oh, you got a new little thing.
Yeah. I use this one when it's actually working properly, because sometimes it isn't. Like, it'll freeze up and do all kinds of weird stuff, but it seems to be working okay today. So we're going to use this one because it has a lot more features to it. All right. So, right triangle problem. So let's do the ones that incorporate these numbers. These are the triples. Do you know the triples?
What on earth are we talking about, fam?
Okay, so here's my right triangle.
Okay.
And there are specific ratios for the sides.
Okay, I'm thinking of what we're talking about now.
So there are 9 triples that you need to know for the SAT. Can you name one of them?
Okay, I've got no idea what. I know it's like a ratio, but I've got no idea.
3, 4, 5. That's 1. 5, 12, 13, 8, 15, 17. So when I'm doing this, I'm saying like the short side is 8, the medium side is 15, and the long side is 17.
What does it have to do with it? I mean, won't they be different numbers? Will these always be the numbers?
They will always be the numbers. If you know 2 of the numbers, then you know the third side.
Yeah.
So let me just write them all out.
Okay.
Because I don't want to lose my train of thought. Okay. 21, 20, 29. Okay, let's see this. Yeah, I think that's right. There's one with 7 in it. 7, 24, 25. And then you have the 30, 60, 90 triangle, and those sides are x, x root 3, and 2x, respectively. And then you have the 45, 45, 90 triangle, and those are x, x, and x square root of 2. Okay, so that's 1, 2, 3, 4, 5, 6, 7. Those are the ones that are actually used the most on the SAT. There is one with 48 and 49 in it, but you rarely see that one. So
these always every right triangle will be one of these combinations.
If it's a non-calculator question, then yes, because they're expecting you to know the ratios and to use the ratios in order to find the answer.
Okay.
So let me show you how to use the triples, because you look confused.
Dude, I am more lost.
Okay, so hold on. So let me get an additional page. Let's one of these things. There's another way to add a page. Okay, never mind. Okay, there we go. Just added a page. So, for example, let's say, and I'll give an easy one. Let's say this side is 6.
Okay.
And this side is 8. And they're asking you to find that side. Okay, and it's a right triangle. So this is how you attack the problem. You find the number that's common to both 6 and 8. What number is common to both 6 and 8?
2.
2. So I put 2x there. Because all the numbers I'm going to multiply by 2. So if I divide this number by 2, what number does that become?
3.
What number does that become?
4.
And remember, the triple is 3, 4, 5. Right?
Yeah.
So that's the side I don't have.
Yeah.
So I take 5 times 2, and it gives me what x is.
Oh, okay.
So what's x?
10.
That's how you use it.
So you don't have to divide 6 by 2 or anything? You just keep it...
Well, I did divide 6 by 2 to figure out what triple I had, right?
Oh, you're finding what number is common. Okay.
You find the common number in order to identify the triple, and then you use the third.
Okay.
Okay, so let's say this is my triangle.
You're dividing it by 2 to get the numbers of the triple. Okay, makes sense.
So let's say I have 39 and 36, and I want to find this side.
What numbers common to both of them?
Mm-hmm.
3?
3. So we write 3x there, because this triangle is going to be multiplied by 3 times, so
12 and 13.
So this is 12, and that's 13. And so what would this side be? The triple is 5, 12, 13. What number am I missing?
5.
So
So
what would,
15.
so this would be 15.
Okay, that makes sense.
So all those triples that I wrote up on this page go in that order.
So I need to memorize these triples.
You need to memorize those triples.
Wait, go back to the other page real quick. I got a question. The hypotenuse is always the biggest side, right?
Yes.
Okay, so if that's the case, then you have 39, 36,
And 15.
15.
So what's the
Oh,
problem?
hold on, never mind. I was looking at 13, 12, and 15. My train of thought was off. Okay, never mind. I got you.
We good?
Yeah, we're good.
Okay, so now I'm going to do another page for now. So let's say I have, this is 30 degrees, and that's a right angle. And I know that this number is 10. Here is the triangle generally. If that angle is 30, then opposite the 30 side is x. This angle would be what then? That one.
60.
And opposite the 60,
90. What?
opposite the 60 side is x
okay.
root 3.
Oh, okay. I've got no idea what.
And then opposite the 90 side is 2x. You need to actually probably draw that picture because you're going to be using that one a lot on the SAT.
Okay.
So if this side is 10, then what would this side be?
This is 10.
10 is related.
X 20.
So this side would be 20.
Okay.
What would that side be?
10 times the square root of 3.
And you write it exactly that way. 10 root 3. You don't do anything else to it.
Okay.
Okay? So you're just going to literally match the sides with the triangle.
Okay, that's it?
That's it.
Okay.
I gave you the easy one first, so let me give you another example. This is 30. That's 90. This side is 18. Find the other sides of the triangle.
Okay. So, x would be 9.
What side is x on?
That right there. And then 9 square root 3.
What if this is 6 root 3, and that's 60?
And that's 60?
Sorry, I'll keep this triangle the same way. That's 30, and that's 90. Find the other sides.
Okay. 6 root 3. That means that side, right. Right here is 6.
Nope.
Right? No. Is it normal sides?
What is this side? What is that side of the triangle? Which side is that side of the triangle up here?
2x square root 3.
No.
2x?
It's the 2x side. So what you have is you have 6 root 3 is equal to 2x. Can you solve for x?
Yeah. But 6 times square root 3 is square root 3.
How do you move the 2? Let's start there.
Divide it, right?
Mm-hmm.
Yeah.
Which one of those numbers can the 2 divide into? The root 3 or the 6?
6.
Only the 6, because those are the two same kinds of numbers. So what is x equal to then?
3 square root 3.
Uh-huh. So this side is 3 square root of 3. What would that side be then?
3 square root of 3 squared. No, that's not right.
Say it again. It might be right.
3 square root of 3 squared.
3 square root of 3 squared.
That,
3 square root of 3 squared.
okay.
So what happens to the square root there?
Squares, because you're adding another square root to it.
No. Okay. So I'll go over this with you with radicals. This cancels the radical.
Oh, okay, so it's just 3.
So what's 3 times 3 equal
9.
to? So that side is 9.
So you won't write it as 3 square root 3 squared?
No, you write it as
Okay.
9.
Got it.
Okay. You do need to know how to do that math, though. And that's why I gave you the question that way, because you will see that on the SAT. Sometimes they won't give you the easy ones. They'll give you something like that on the SAT.
All right.
Because they expect you to know how to do that math. All right, so I'm going to delete this. I'm just going to clear this. Ooh, I didn't mean to do that. Delete. So this side is 30. That's 90. And this is 12. Find the other two sides.
Okay.
Do I need to draw the other triangle for you? Okay.
Let me see if I can get it. I can't. Would that side be 3 by any chance? No? Okay, then I've got no idea.
Alright. If this is 30, label the sides for me. Tell me where to put the 2x, where to put the square root of 3, where to put that.
2x, x square root of 3.
Okay, so this is 2x.
X.
That's
square root of
x,
3.
and that's x root 3. So what two sides are the same?
X square root 3.
And?
Oh, yeah, 12.
So you're doing a math equation with that. Eventually, I'm hoping that you see that there's a pattern here. How do you solve for x?
Square?
Nope.
I mean,
That is just a number. So how do you move that number over to this side?
divide.
Divide. It's just a number. I know it has the square root over it, but it is still just a number. So those two cancel, right?
Yeah.
How do you rationalize that? How do you get rid of the square root on the bottom?
You square? Isn't that how you...
No.
No.
So
okay.
watch this.
I thought the inverse.
What I'm going to do is I'm going to multiply the top and the bottom by the square root of 3. What is square root of 3 divided by square root of 3?
1.
So have I changed the number? No. Right?
Yeah.
So the square root of 3 times the square root of 3 is equal to what?
1.
No.
Square root of 9. Square root of 3.
What's the square root of 9?
3.
3. So when you do that, what happens to the square root?
It disappears.
That's the whole point.
Okay.
Now I got to multiply the top. So I have the square root of 3 times 12. Can I do anything to those two numbers?
No.
No. So this just is 12 square root of 3. Can I do anything to these two numbers, though?
Yes.
So what is that going to be equal to?
4 square root of 3.
So this is 4 square roots of 3. What would that number be?
8 square root of 3. Okay.
Remember, let's see if you can see the pattern. When this was 30, and this was 9, this was 3 root 3, and this was 6 root 3. Do you see a pattern there? Or do we have to do it one more time?
Hold on. Yes.
What's the pattern?
Oh, hold on. That's an 8 square root 3. Yeah.
Mm-hmm.
I can see it. My brain just needs a minute to process it.
All right, let's do one more.
12, 4, and 8 are all divisible by 4. Well, 6 and 9 are all divisible by 3.
How do you change from this number to that number? Just the part that's underlined.
Divided by 3.
How do you change from this number to that number?
Divided by 3.
So if I have 15 down here and this is 30, then what would the other two sides be?
5 square root of 30.
And
10 square root of 3.
you see the pattern now?
Yeah.
Makes it easy,
That's
right?
much easier.
Instead of doing all this googly goggly gook.
Yeah.
Right?
Yeah.
That's why it's important to recognize the patterns. There are a ton of patterns on the SAT.
Okay.
All right. Okay. So that was actually the hardest part. We've done the 60 side, we did the 30 side, we did the 90 side, right? So we did all 3 sides of that.
30, yeah.
If you need to review that, this is being taped. So I'm going to move on to something else. Let me clear this. You will almost never use the Pythagorean theorem on the test. You will always use a triple or SOHCAHTOA to do something, right? So let me go over SOHCAHTOA.
Yeah, I got Pythagorean theorem, but I forgot SOHCAHTOA, I think. No, we had some side opposite. No, I'm thinking of something wrong. Never mind.
So they will label an angle. Let's call that angle theta. So everything is in reference to that angle.
Okay.
So when you see a triangle, you have to label the sides of the triangle according to that angle. This side is like the side you see. It's the observed side, so they call that the opposite side.
Okay.
The hypotenuse is always opposite the right angle, and the adjacent side is always right next to the angle.
Okay.
So all of these are ratios according to that angle. So sine is equal to opposite over hypotenuse.
Cosine is equal to, okay, I remember it now. Tangent.
Okay, so now, oh, actually I don't want to clear that. So if I have this, and I say that this side is 20, let's say I didn't know the triple thing, right?
Okay.
And I wanted to find...
Wait, does the triple thing work all the time?
For 30, 60, 90 it does, because this happens to be a 30, 60, 90 triangle.
Okay.
But I'm going to use this as an example using this stuff, right? Because I want to show you where the numbers go.
Okay, hold on, one question here before we get started on this.
Mm-hmm.
So we have the triangle with 2x, x squared root 3. If it's not 30, 60, 90.
Then it doesn't work.
Okay, got it.
Then you have to use SOHCAHTOA.
Oh, no, you have to use the math or something.
You have to use,
okay,
right.
Okay.
So I'm using something because I should know that this number should be what?
Oh, 10.
10. The answer should be 10, right?
Yeah.
So let me show you using, I'm using an example of something that we've already done just to prove it.
So 20, 10 to 30, right?
So the 30 goes with the sign. So the first thing that I'm going to do is I'm going to label the sides. I have the hypotenuse and I have the opposite side.
You need the adjacent.
I don't need the adjacent because I only am dealing with those two numbers.
Oh, we're looking at sine?
We're looking at sine. So we labeled the sides to figure out which of these 3 trig functions I'm going to use. Because I have those two sides in my problem, I'm going to use sine.
The sides you have will dictate what you're using.
What you're using.
Okay,
right. So I have the sine of 30, because that's the angle, is equal to hypotenuse over opposite. So this is x over 20.
Okay.
So I solve for x. So that means I have to move this number up there. So this is 20 sine of 30 equals x. So when I do that in my calculator,
20 sine 30.
and hopefully I haven't changed this to radians. Oops.
Do you have to change that to radians?
You might. I think I have mine set to degrees right now, so it should be okay. So we got 10.
Okay. Cool.
So you're gonna put the numbers where they're supposed to go. The angle goes with the trig function, and then these numbers go in a particular spot. Okay.
All right.
Here's the other thing. So let's say I have a word question. So let's say that I want to know if I have a building that is 100 meters high.
Okay.
And it casts a shadow that's 120 meters.
Okay.
Then how far is it from the top of the shadow all the way to the top of the building?
So this is like one of those ladder against the ground of the wall.
Right. Right. So that's a right triangle, right?
Yeah. 90.
So what am I actually looking for? What side am I looking for?
The hypotenuse.
Okay. Oh, let's say if I drew, I'm gonna change it. I'm actually gonna make it a ladder question. I want to know what angle the ladder is laying against the building.
This isn't a 30, 60, 90 question.
It's not a 30, 60, 90 trig. We have to use trig to do this question. So I want to know what. Okay, so here's my ladder. It's laying across the building. I want to know what angle is the ladder laying across the building. So I want to know this. And then I also want to know how long the ladder is. So I want to know that. So it's a two-part question.
Okay.
So the first thing that I do is I label the sides that I have. What sides do I have?
You have the opposite and adjacent.
That's the opposite side. That's the adjacent side. What trig function am I going to use in order to find theta?
Tangent.
So the tangent of theta is equal to what over what?
Will it always be theta, or do you just use theta?
Yes, it will always be theta, because that's what I'm going to label an angle. I'm just going to call it theta always.
Okay. All right. So it's going to be 100 over 120.
Whenever you are solving for the angle, instead of using the trig function, you use the reciprocal function. Not the reciprocal function. You use the inverse. So in order to solve for theta, I have to say tangent inverse of my ratio. That's where that negative 1 comes from, because I'm actually solving for
120 over 100?
Mm-hmm.
Okay.
It's the exact same ratio.
Can you just plug it in as 120 over 100, or do you have to use negative 1?
No. I'm going to show you.
Okay.
You always be jumping the gun, man.
I know.
You see that right there?
Yes.
That's tangent inverse. So I'm going to hit second tangent, and then I'm going to hit 100 divided by 120.
All I was saying was like, can you do tangent 120 over 100?
And you'll get the wrong answer.
Okay, got it.
Instead of getting that angle down there, you'll get that angle up here.
Okay.
When you do that. So you have to put them in that order, because you said that was the opposite side and that's the adjacent side. So tangent is opposite over adjacent. See, the ratio doesn't change.
Got it.
So that means that angle is 39 point, what's that, 0.8? Oops. 39.8. Okay? Now I want to find the hypotenuse of that triangle. So if I use hypotenuse, I have to choose which one of these sides I'm going to use, because I have this angle and the hypotenuse. So what other side do you want to use?
Adjacent.
Okay. So if I have the adjacent and the hypotenuse and the angle, what trig function is that?
Cosine.
So I'm going to say the cosine of 39.8 is equal to what over what? What's
120 over h, right?
120 over h. Now, when the h is on the bottom there, these two things just switch places.
Okay.
So h is equal to 120 over the cosine of 39.8. So I'm going to do that in my calculator.
Money, fame, power.
Yeah, money, power, respect. Remember that.
Yeah.
Okay, so I'm going to say cosine of my answer divided, oh, sorry, I did that backwards.
It's okay.
120 divided by the cosine of my answer. And so that is equal to 156. So in the question on the SAT, they won't actually ask you to find that intermediate part. They'll say, how long is the ladder? And so you'll have to do both steps in order to figure out what how long the ladder is. Okay?
Okay.
All right, so that's the right triangle stuff. So let me cut off this video. Uh-oh. Did I shut it down or something?
Did you?
No, it's still there.